Hello friends, welcome back to my YouTube channel. So in last video we have seen the how to develop the flexibility matrix for the frame. So by using the flexibility method. So we have seen the development of the flexibility matrix in last video. So today we'll solve a problem on that. So the problem is like this. Analyze the portal frame by flexibility matrix method. So this is the given frame. So here both the ends are fixed. Here on point load of 100 kN is acting. So now our first step is to find out the DS. DS is nothing but degree of static indeterminacy for the frame. For that we have the formula. So I have already made the separate video for the degree of static indeterminacy for plane frames, how to analyze this. So by using this formula we need to find the DS for frame. So this video link I will give in the description box. You can go through that video if you don't know how to find the DS in details. So by using this formula we will calculate the degree of freedom. So here M is nothing but number of members and R is nothing but number of unknown reactions minus 3 into J is nothing but number of joints, and here R is nothing but number of internal hinge. So our formula is ds is equal to 3m plus R minus 3j minus R. So by using this formula we will find out the ds. So ds is equal to 3m plus R minus 3j minus R is internal hinge. So there is no internal hinge, so it becomes 0 here. 3 into how many members? Members are 1 2 3 3 members. 3 into 3 plus how many reactions? Here 3 reactions, here 3 reactions, total 6. Minus 3 into how many joints? 1 2 3 4. Number of joint is 4. So now solve it. So ds will come out as 3. So 3 means we have the 3 numbers of redundants in this problem. So this is a statically indeterminate. To make it statically determinate, we need to remove the 3 numbers of redundants in this structure. So we need to release the 3 numbers of redundant. So I am taking the here at support D to release the 3 numbers of redundant. So I will give the vertical and horizontal and one moment. So I will give for the horizontal one coordinate number 1, this is nothing but call it as ST, and vertical one coordinate number 2, this is the vertical one VD, and one moment. So MD I am giving it coordinate number 3. So we need to release the 3 numbers of redundant here to make the structure statically determined. So I will read out the diagram here. So after finding the ds we need to redraw the diagram, and at a time we need to put the only one coordinate at that diagram. So I will first redraw here and I will show. So this is the diagram after releasing the redundant. This is the diagram. So give the, and this is the diagram of the each coordinate. So now here at a time we need to put the only one coordinate. So coordinate number 1 is acting here, we need to put that, and it has the intensity of 1 kilonewton, you all know, and give the name A, B, C and D. Coordinate number 2, that is vertical, it is acting here. I will give it has the intensity of 1 kilonewton, we need to apply the 1 kilonewton and give the name A, B, C, D. Here also A, B, C, D. Apply the coordinate number 3, the moment it is acting here, it has the intensity of 1 kilonewton. Here at a time we have to apply the only one coordinate at the each diagram. So here we need to remove all the actual loads that is given in problem, and we need to apply the only one coordinate which you want to find out. At a time we need to put the only one coordinate on this diagram. So we have to remove all the actual loads here, and this is called our M, capital M. This is called M1 coordinate moment of coordinate number 1, and this is M2 moment of coordinate number 2, and this is M3 moment of coordinate number 3. And now what we have to do is we have to draw the unit load table like this and fill all the, so it has the member and origin, EI, limit, M1, M2, M3. So for member we have the member, I am calculating from left side to right side. We have the member DC, CB and BA, so same thing I have written here. For DC I am taking the origin, so I am taking the origin as D, and for CB I am taking the origin as C, for BA I am taking the origin as B, and for DC we have the EI value I 1 EI, and for CB we have 4 EI, for BA we have 4 EI, so 4 EI, here also 4 EI, and limit for DC the distance is 5 meter, now 0 to 5, and for CB distance is 10 meter, limit is 0 to 10. For BA we have the distance is 10 meter, so limit is 0 to 10 again. So now we need to find the moments. We'll see for M, for member DC, if we cut the section, if we cut the x-axis, we have taken the origin as D, away from the origin D at a distance of x. So here there is no load here, so it means our moment becomes 0. Similarly for M1, if we cut the section x-axis away from the origin D at a distance of x, so here one unit load of 1 kilonewton is acting, so it is going upward, so we all know the sign convention upward, we need to take the positive, and which is moving downward we need to take the negative, so it is going upward, so 1 into x is nothing but 1x, so x. Similarly for M2, if we cut the section x-axis away from the origin D at a distance of x, so 1 kilonewton is acting axial to this member, so it becomes 0. So M2 becomes 0. Similarly for M3, if we cut the section x-axis far away from the origin, so our movement is rotating here like this, no? So it is rotating clockwise, but it is moving down, no, it has a negative effect on this member, so we need to see the what is the effect of the moment on this member. So it is pushing member to the downward, we need to take the -1, so it has a negative effect on the member because it is pushing this member to the downward, for that moment becomes -1. So we don't need to see the, you may say it is rotating clockwise, now we need to take the positive. We should not see the whether it is rotating clockwise or anti-clockwise, we have to see the what is the effect of this, movement on this member we need to see. So it is pushing this member to the downward, so it means we have to take the -1. Similarly now we will see for the CB, we have taken the origin as C. For CB, if we cut the section x-axis away from the origin C at a distance of x, so here there is no load, so moment for CB becomes 0. So similarly for M1, member CB, M1, if we cut the section x-axis far away from the origin C at a distance of x, we need to see from here, so what is the perpendicular distance of 1 from this section. For BC, the perpendicular distance is, it is a CD. So for CD we have the 5 meter length, so it becomes 5. For BC the moment is 5. Similarly for M2, if we cut the section x-axis far away from the origin C, so what is the perpendicular distance of 1 from this section is x. So it is also going upward, now we need to take the positive, so x, 1 into x is nothing but x, or M2 value is x. For M3, if you cut the section x-axis far away from the origin, C, the moment, so it is also -1, it becomes -1. How? In previous video I have explained how the moment transfers from here to here and here to here, so you can If you don't know, you can go through that video how moment transfer I have explained in detail. So for this member also, it rotates, it has a negative effect. If it comes moment here, it also pushes this member to the downward, pushing member to the downward. It means -1. So it also -1. For BA, origin we have taken as B. So if you cut the section away from the origin B at a distance of x, so here on point load is acting now, it is also coming downward. So moving downward means we need to take the negative. So at a distance of x, 100 into x. So m will be -100 into x. So now for m1, if you cut the section x-axis away from the origin B at a distance of x, so for 1 kilonewton comes here, it also acts like this downward. So it means -1. So -1 into, to find this distance we need to minus this distance, minus we need to do this distance. It means x minus the distance of CD is 5 meters. So x minus 5. So it will come 5 minus x. So simplify 5 minus x. For m1 we have the value 5 minus x. 5 minus x. For m2, if you cut the section x-axis at a distance of x far from the origin, so 1 kilonewton. So what is the perpendicular distance of 1 from this section? So from this section is perpendicular distance is BC. So BC is perpendicular to this section. The distance of BC is 10 meter. So for m2 we have the value 10, because the perpendicular distance from this section is 10. So 10. Similarly for m3, if you cut the section x-axis away from the origin, so moment will be same. It also rotates like this, -1. It rotates downward, it comes -1. -1 for m3. So this is how we need to fill the unit load table. Now it becomes 3 into 3 matrix. We need to, flexibility matrix will come F11, F 3 into 3 matrix will come. We need to now find the F11, F12. So I will show 11. We have the formula integration of 0 to L m1 square divided by EI into dx is equal to, now substitute all the value. For CD, m1 is x, limit is 0 to 5, integration of 0 to 5, m1 is x whole square, so EI value is 1 into dx plus, for CB limit is 0 to 10 and m1 is 5 square divided by EI is 4. So 4 EI into dx plus integration of, for BA limit is 0 to 10, m1 is 5 minus x whole square, EI is 4 divided by EI into dx. So now solve it. Integration of 0 to 5 into x square x whole square plus integration of 0 to 10 into 5 square divided by 4i divided by 4 plus integration of 0 to 10 into 5 minus x whole square divided by 4. Now solve it. Our F11 value will come out as 120. Sorry, it's 125 EI. 125 divided by EI. Similarly for F22 we have the formula integration of 0 to L m2 square divided by ei into dx is equal to integration of 0 to for dc 0 to 5. For 0 to 5, here m2 value is 0, so we don't need to find this. For cb, we have the limit 0 to 5, sorry 0 to 10. 0 to 10 into x square dx divided by 4 ei plus integration of, for BA limit is 0 to 10, 0 to 10 into 10 square divided by 4 ei into dx. So now solve it by using calci. So you all know how to calculate by using the calci, so I am directly writing the answer here. So it will come out as 333.33 divided by ei. Similarly for f33, 0 to L m3 square divided by ei into dx. So for m3, so all the values minus 1 minus 1 minus 1. So integration of 0 to 5 minus 1 square dx plus integration of 0 to 10 minus 1 whole square divided by 4 ei into dx plus integration of 0 to 10 minus 1 square divided by 4 ei into dx. So now solve it. So it will come out as 10 divided by ei. So now for f12 is equal to f21 is equal to integration of 0 to L, we need to multiply the moment of first point, here also moment of first point. So m1 into m2 divided by ei into dx, so is equal to integration of, so here m2 value is 0. If you do 0 into anything, it will become 0, so I am not doing for dc. So now we will see for the cb, we have the limit 0 to 10 and 5 into x. 0 to 10 into 5 into x dx plus integration of 0 to 10, integration of 0 to 10 and 5 minus x into 10. 5 minus x into 10 into dx. So if you do, it will come out as, so put ei value is 4 ei value, here also 4 ei value. Now solve it, it will come out as 62.5 divided by ei for f12 and 21. Similarly for f13 is equal to f31, integration of 0 to L m1 into m3 divided by ei into dx is equal to integration of this into this and this into this and this into this. So limit is 0 to 5, 0 to 5. So x into minus 1 dx plus integration of 0 to 5, 0 to 10. So 5 into minus 1 divided by 4 ei into dx plus integration of 0 to 10. 5 minus x into minus 1 divided by 4 ei into dx. Now solve it, it will come out as minus 25 divided by ei. Similarly for f23 is equal to f32, integration of 0 to L m2 integration of 0 to L m2 and m3 divided by ei into dx is equal to integration of, for dc m2 value is 0, this into this 0 and anything becomes 0. I am not doing it. For cb, this into this and this into this, integration of 0 to 10 x minus 1 divided by 4 ei dx plus integration of 0 to 10 into minus 1 dx divided by 4 ei. So solve it, it will come out as minus 37.5 divided by ei. Now we have solved all the values, so put here f11 value we got was how much, we got was 125. So 125, f12 value we got was 62.5. So 62.5 and F21 value is also 62.5. F13 value we got was minus 25, so minus 25, here also minus 25, F31, and F22 value we got was 333.33. So 333.33, this is not point here. And F23 value we got was minus 37.5, minus 37.5. F32 value is also minus 37.5. F33 value we got was finally how much? We got was 10. So put it here into 1 divided by E. I am taking constant. So otherwise if you assume EI value as constant 1, so it becomes 1, or otherwise you can keep it like this only. So now what we have to do is, by using the compatibility equation, that is P matrix is equal to matrix of delta universe and delta matrix minus displacement matrix. So our DL is nothing but D1 and D2 and D3. DL matrix is nothing but, so how many redundant we have, that much of we need to take the DL matrix. We have the 3 redundant, we have got the 3 numbers of redundant. For that we need to take the 3 into 1 matrix. DL is 3 into 1 matrix, D1, D2 and D3. So now we need to find the D1, D2 and D3. I will show how to find. You all know already. We'll solve here. So for D1 is equal to integration of 0 to L capital M into M1. For coordinate 1 we need to take the moment of coordinate number 1 divided by EI into dx. Now we'll substitute all the value and see. For DC we have the M value 0, 0 into anything becomes 0. Here also for CB we have the M value 0, 0 into anything becomes 0. So now we need to calculate for BA. So limit is 0 to 10, M is minus 100x and M1 is 5 minus x. So put here 0 to 10 into minus 100x into minus M1 is 5 minus x divided by EI is 4 divided by EI into dx. So now solve it by using calci. It will come out as 2083.33 divided by EI. So you all know how to calculate by using calci. That's why I am directly writing the answer here. For D1, for D2, integration of 0 to L capital M into moment of coordinate number 2, that is M2 divided by EI into dx is equal to integration of, see here also M value 0, this into this becomes 0 and this into this becomes 0, this into this becomes 0. For BA we need to calculate, this into this we need to do. So limit is 0 to 10, integration of 0 to 10 minus 100x into 10 minus 100x into M2 value is 10 divided by EI value is 4 EI into dx. Now solve it. So it will come out as, here 4 EI, right, 4. So by solving it will come out as minus 12,500 divided by EI is our D2 value. Similarly solve for the D3. D3 is equal to integration of 0 to L capital M into M3 moment of coordinate number 3 divided by EI into dx. Dx is equal to integration of, now see here, this into this into this and this into this. For DC and CB we have the 0, we no need to calculate. So for BA we will see integration of 0 to 10 minus 100x into minus 1 divided by 4 EI into dx. Solve it, our D3 value will come out as 1250 divided by EI for D3. So now we'll put this value in this matrix, d1 value and d2 value and d3 value. D1 value we got was 2083.33. So 2083.33 and d2 value we got was minus 12,500 and d3 value we got was 1250 divided by 1 divided by ei. I am taking constant. So here also assume ei value as constant, that is 1. Take 1. So now we need to do, so here compatibility equation, from the compatibility equation, so here delta value yielding value becomes 0 and now put the all the values. P matrix is nothing but how much redundant we have taken, that much of p value we need to take. We have got the 3 number of redundant, for that we need to take the p matrix is also p1, p2 and p3. It becomes, and integration of, sorry not integration, now put the flexibility matrix all the value here. 125 62.5 minus 25 62.5 333.33 minus 37.5 minus 25 minus 37.5 and 10. So now we need to do the universe of this, and into minus of DL matrix we need to put here. D1 value is 2083.33 minus 12,500 and 1,250. Now solve it by using calculus. How to solve it I will tell you. So here press the mode, here add 6 matrix is there, we need to press the 6 here, and your matrix is at number 1, press 1. Now here see, for our A matrix is 3 into 3, 3 into 3 matrix is at number 1, press 1 and 1. Now fill all the values. 125 is equal to 62.5 is equal to minus 25 is equal to 62.5 is equal to 333.33 is equal to minus 37.5 is equal to minus 25 is equal to minus 37.5 is equal to 10 is equal to. Here now press the AC. So press the AC and again shift and again come to 4, press the 4 here. You could see the data here at number 2. So now press the 2, go inside the data and you could see the matrix 2 is at number 2, press 2 here, and our matrix B is 3 into 1. No, for that here see here where is 3 into 1 matrix, put here universe. 3 into 1 matrix is at number 3. No, now press the 3. So now enter all the value in this matrix. So 2083.33 is equal to minus 12,500 is equal to 1,250. So now here again press the AC here, once again press the shift here and again press the 4, number 4, and now you could see matrix is at number 3. So now press the 3 here, here matrix A came. Now we need to do the universe of this. So press this one. Now into minus 1 into matrix B, minus 1 into again shift 1 and again 4. Here matrix was at number 4, press 4 here and close the bracket. Now solve it. So our P matrix will came. See here, so minus 68.62 is nothing but our P1. So now write it here, I will write it here. P1 is minus 68.62 and P2 is 29.41. is P2 value, and P3 value is minus 186.27. P3 is minus 186.27. So now we got the P1, P2, P3. So our P1, P2, P3 is nothing but these coordinate value, that is P1 is nothing but our HD value. And P2 is nothing but our VD value, coordinate number 2, and coordinate number 3 value is our MA is nothing but P3 value. So we have got all our coordinate value which we have taken. So HD is equal to P1 and VD is equal to P2 and MA is equal to this P3. So now we have calculated all the coordinate values. So this is how we need to find here our problem. And so if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.